And a very good morning from BBC Two, where our daytime programmes follow in just under a minute with mathematical investigations. So now we begin this morning here on BBC Two with mathematical investigations, attempting to get the facts.
There we are. Drive carefully.
Thank you. He's lending me his car. I'm not particularly short, but this is ridiculous. Or is it? After all, men are taller than women. Okay, no need to make a song and dance about it. Perhaps it's not true. No, must be. Mustn't it? Could you test a statement like that? Do you remember what the statement was? All right. Is this a suitable place to test that statement? Or, if it isn't, are there any useful statements we could make about the height of the people you've just seen? You may like to know that each member of this population, in other words, every one of those pupils, is 12 years old. Hello again. Here come some more statements about people. See what you make of them. Excuse me? Oh. Oh, good. Okay, go ahead. And that includes you. How about the next statement? Okay! Is that statement true? Can you improve on either of these statements? And how could you test them? Nine out of 10 pupils you can see are wearing MI10 t-shirts, but the rest of the school isn't. So it's not true that 9/10 of that population
are wearing MI10 t-shirts. And even if they were, it doesn't mean that they watch this series. There could be another reason.
I expect you guessed what we were up to. It was an unfair sample, to put it mildly.
What the BBC really does is to send out a questionnaire to a random sample of about 1,000 of the 6,000 or so secondary schools in the UK. It asks them what series they are using each term. We won't have a good estimate for the size of the MI10 audience until sometime after it's been shown.
Now, what about that statement, all school pupils like pop music? What sort of music do you like?
Pop music.
Any other type of music?
Classical.
You play an instrument?
Yeah. Clarinet.
What sort of music do you like?
Pop.
Any particular group?
Duran Duran.
Pop. Do you have a favourite group?
Probably Frankie Goes to Hollywood.
I like pop music.
And what else type of music?
I don't really mind.
Pop.
What about classical? Do you like classical?
Yes, okay.
You have a favourite composer?
Tchaikovsky.
I don't have a favourite, like all sorts.
Do you like classical music?
Well, not really. I like pop.
Well, mostly pop, but all kinds, really.
Do you like classical music?
Some.
Pop music.
Do you like any other sort of music?
No, not really. Pop.
Is there any music you don't like?
No.
Is there any music that you really hate?
Heavy metal.
It should be pretty clear that not everyone likes all forms of pop music, and fashions keep changing. So perhaps the only useful statistic is sales of records. But there are plenty of people who buy a record just because it's already in the top 10 best-selling records and is being played a lot by disc jockeys. So it's quite difficult to discover what music people really like if they're not influenced by other people. This seems a rather easier statistic. Height is certainly something we can measure. We measured the height of everyone in this school aged 12.
First, the girls. We grouped them according to ranges of height. For instance, 135 to 139 centimetres, 140 to 144, and so on. And now the boys. Are they taller? Let's see each of those as a diagram. The most popular range, or modal range of heights for these girls, is 155 to 159 centimetres. 30% of the girls were in this range. The boys' heights were more spread out. Their modal range is only 150 to 154 centimetres, but there are more of the very tallest boys. In the range 135 to 139 centimetres, there are just 7 boys. The midpoint of this range is 137.5, so we won't be far out if we think of each boy as 137.5 centimetres tall. If you put them end to end, their total height would be 7 times 137.5. That's 962.5 centimetres. We did this for each range. We worked out the midpoint figure and multiplied by the number of boys to get the total height in each case. If you put all the boys end to end, their heights would add up to this figure, about 1.5 times as long as a football pitch. How does this compare with the girls? The girls' total height is more, but it's shared between 100 girls. The average amount per girl, or the mean height of the girls, is 154.8 centimetres. There were only 94 boys. Their mean height comes to 154.04 centimetres.
So I think we're ready to make a fairly precise statement.
In this school, the mean height of the 12-year-old girls is greater than the mean height of the 12-year-old boys. Does it apply in your school to pupils of your age, 1 year older? Are people in the south of England any taller than the people in the north? Are they heavier? Are heavier people taller? Do tall children have tall parents? Are people who watch MI10? It's amazing to think that Stonehenge was built some 4,000 years ago, in about 2000 BC. It may have been built as a kind of temple. The problem is, how did people 4,000 years ago manage to move these massive stones from a long way away, probably in Pembrokeshire, to here? One theory is that they pulled them. To test that theory, an archaeologist made a concrete slab the same size and weight as one of these and got some boys to pull it. All that was way back in 1957, and BBC television was there.
With the copied bluestone lashed in position, the weight to be moved is about 1.5 tons. Now, with 24 gallant volunteers from Canford School hauling, off we go. But no, 24 can't do it. Can 28? No, it's still too much for them. Can 32? Yes, they can, and off the sledge goes.
It would have taken about 40 men to move the stone over long distances. It's pretty hard work hauling the stone in this way, but one theory is that the ancient people made it easier for themselves by rolling it on logs. This time, 4, 8, 14 boys did the hauling, and less than half the previous hauling party moved it quite easily. The difficult thing is getting the rollers into the right position. It takes careful organisation and lots of people to move them. The slab is moving at only about 1 mile an hour. But the people bringing the rollers up from behind are having to move a lot faster. Can you think precisely why that should be? If I move this slab so that the roller goes through exactly 1 revolution, how far would the slab on top move? Let's take a look at that. The arrow shows our starting position. The stone marks the position of the roller on the ground. This stone marks the position of the slab on top of the roller. Now, if I move the slab so that the arrow head points upwards again, there. Now, you can see the slab has moved from there to there. That's twice as far as the roller has moved from there to here. Why should that be? Do rollers have to be round? These are elliptical. Let's try them out and see. Well, that's not very good. Too much effort is wasted in lifting the slab. Let's try another shape. These are different. Well, that seems perfectly smooth. The shape of the roller is interesting. You often carry a shape similar to this in your pocket. This is one, a 50p piece. Its edge is a rouleau curve. If you're rich enough, you could make 2 rollers out of these, like this. And then you could try out the rolling experiment. What's special about this shape? Another interesting thing, what happens when you use these rollers as wheels? There. It's amazing what shape hole you can drill if you really try. This is a Watt's drill. The bit, which actually makes the hole, is based on a rouleau curve. And this is the guide plate, a square in this case. This model shows how it works. This is the guide plate. And this roller just fits inside and moves around. The roller has cutting edges put on it, like this. So as it moves, it cuts the metal underneath. As it moves around, the centre wobbles. So a special wobbly chuck is put on the drilling machine. Watt's drills can make many different shape holes. Do you notice how many cutting edges there are here? What shape hole would this make?